So today we'll be going over this free code camp problem, which is game of life. And in this specific instance, I'm going to take us from if you just know about one-dimensional arrays, so something like this, 1, 2, 3. And if you know how to use a for loop to iterate over that, I'll try to take us to get to being able to do multi-dimensional arrays like 2D arrays like this problem requires, where you'd have an array inside of an array, which is helpful to signify something like a game board. Like on the left side of this, there's a 3 by 3 array, or sorry, a 3 by 3 matrix. And these are represented by multiple arrays in those arrays. So just to get a purview, or I guess a good idea of what the audience knows, everybody has worked with one-dimensional arrays here, right? Everyone's pretty familiar?
Yes.
Yes.
Okay. And then, assumedly, 2D arrays are a new concept. Is that right?
Absolutely.
Okay.
Not completely new, but this type of problem is new to me.
Okay. Sounds good. So I'm going to start us off like, if we start out with this whole giant problem, it would be pretty difficult to get started with. So I'm going to ignore a lot of these rules for starting. Just take the simplest way to go forward and move forward from there. So to start out, we're not even going to use a 2D matrix to do it. We'll figure out how to do it with a 1D array and then go from there. So the rules here is we have an array like this, which they call a matrix, and we want to get the next state of the game, which is represented by a new array. So for example, here we have this input and we get this output. Don't worry so much about what exactly the rules are or anything for now. But the important things here is we either have a 1 or a 0, which means alive or dead, and then in this case, the cell's neighbors are the 8 surrounding cells, but if we have one-dimensional, it'll just be the ones left and right. And we'll focus on that for now. So in this case, for 2, the neighbors would be 3 and 1. And of course, in the actual version, we would have only 0s and 1s. And then the other rule here, it mentioned cells on the edge have fewer than 8 neighbors, which just means if I take this leftmost item, this leftmost cell, which is 1, it only has one neighbor, which is the one to the right, because outside of this edge is not a neighbor at all. And then there's lots of different rules, which we will forego for now. But so there's a certain amount of live cells around. They'll either die, live on, or if they're dead, they can come back to life with different rules for all of those. So for now, I am going to throw this to the side so it's not distracting and we can get started with some things. I usually like making variables for alive and dead just to make it easier for us. Because I find looking at 101 is way harder than looking at something like this. We'll still, of course, see the 101 over here in the logs, but just makes it a little bit easier. So one of the rules we had when taking in this array is if there's a certain amount of neighbors, they will either live, die. I'll bring these back. So we can have our states of dead to alive. We can continue to stay dead. We can go from alive and stay alive. And we can go from alive to then dead. So in this case, we have fewer than 2 means they die. And we'll say, let's say, for now, if less than 1 live neighbor, then the current cell dies. And then if it has 2 or 3 live neighbors, then it lives on. So if it's equal to 1, then we're going to say it lives. And then with more than 3, it dies. So I'm going to say if it is greater than 1, then it's going to die. And then if it has exactly 3, then it will continue to live on in this case, but it'll die in this other case. And we'll say if it's equal to 1, it lives or comes to life, because we only have the opportunity of 0, 1, or 2 here. Any questions on any of these rules will all make sense for our simplified rule set?
Everything is good.
Yeah, sounds good. So I think first of all, it makes sense to decide, just make a function to test these out. So we'll take in the amount of live neighbors and figure this out. Should be pretty quick. I'll call it new cell state. So we take in a state, which is a number 0 or 1, and then we are going to get out that new state based on the number of live neighbors. So if our live neighbors is equal to 1, then we always want to make it live. So we're going to say alive, this case. And for now, I'm just going to console log to make sure these all work. So if we have live and live neighbors, I should say 1. Then we expect it to continue to live. So this is a 1, which is exactly what we expect. If we have a dead, we also expect this to be alive at the end, which it currently is. But we don't have the rest of our cases done here. So if it's greater than 1, then the cell dies, and if it's already dead, it stays dead. So anything with 2 will be dead at the end. We expect a 0. So in this case, we get undefined, which makes sense because we haven't implemented this bit yet. So we want to handle that other case. If our live neighbors is equal to 2, then we can return dead. And that should handle both those cases. Great. And then our final state, we have less than 1. So if it's less than 1, the current cell dies. So then in that case, we would just leave it dead there as well. So we probably don't need another case here. We can say our the live neighbors is equal to 0. In this case, it should also die. So we could just copy these. And take in 0 and 0. We expect these to be dead. And yep, they are dead. And in this case, we should never have anything over I'll just put it down at the bottom. But since we can never have anything else for our current implementation, I'm just going to throw an error down here if we ever hit this. If I can spell right. So if I test that out real quick by saying like 10, then yeah, that's an invalid amount. And if it's like negative 10, it's also invalid. So great, that works. So I think we're pretty good to move on. Anyone have any questions about this so far?
Nope.
Sounds good.
Good, thanks.
Yep. Looks like in this specific case, we don't need the state. I think we will need it for the other implementation. But for now, I'll just remove it since we're not using it at all. So now we've broken down these rules based on how many live neighbors we are, but now we need to figure out, first of all, how do we iterate through all of these items? And then two, how do we check how many neighbors there are per each one? I'll start with the first one, but I'll mark these out first. So we need to iterate over the matrix, and then check neighbors, and then get new state based on the rules. So an easy way for our grid, since it's 1D, is we can just use a for loop. So just going to do a standard for loop. We care about the index. So I'm going to this kind of for loop. And let's just do a quick check to make sure that I know how to write a for loop properly. Make sure it's logging everything in each item. So looks like I got that wrong. And now it works, as typical. So usually I end up going with methods to avoid having to write these kinds of loops, but always good to check as early as possible just to make sure we're not breaking anything along the way. But yep, we get it exactly what we expected: 0, 1, 1, 23, 2, and 3. And
Jacob, I don't mean to interrupt, but I wanted to ask you a question. Since everybody is at different levels here, I know you mentioned that you like to use methods to normally like iterate over arrays. Would it be possible if you could use loops for this demonstration? Would that be okay?
yeah, no problem.
All right, cool. Thanks.
Yep. We're already here though with the loop, so we're all good. So moving on to the next bit here, we then need to check the neighbors. So right now we don't have any way to count how many dead or alive neighbors there are. So a new function is in order. We would like to check each one of the neighbors. So get live neighbors, I'll say. And then here I'd like to pass in the grid and the index. So looking at this, I'll pick an actual correct implementation here. So we would expect for our live neighbors, and let's just test this out for now. So we have our grid, and for index 0 here, we'd expect that we have 0 live neighbors, because to the left there is nothing, and to the right we have dead. So how could we check that? We could say, if there's a left neighbor, check if it's alive. If there's a right neighbor, check if it's alive, and then we add those up. So if, I'll just say left is index -1 and right is index plus 1. And there's a few ways we could go about this. We could either manually check, which works well in pretty much any language, or we could use something just check if it's undefined. We could check if it's if it is alive, and if it's undefined because we went out of bounds, or it is defined but dead, then in that case we don't need to worry about it. So I'll show both of those. So the more explicit way of doing it, I would say, is saying if left is in bounds, which would say left is greater than or equal to 0. And then we want to we know it's valid to look at the grid. We can say grid of left is equal to alive. Then our live count is now greater. So we can increase that here. And then we can do the same for the right side when we get to it. But not to get too far into the implementation, let's just make sure this does the right thing. So in this current case, we have 0, which is great. And then if I check the index 2, this is also going to be 0. And if we have a case where just the left one exists, and we pick index 1, then we'd expect there to be one live neighbor. So in this case, we're looking at this index here, index 1, and looking to the left and seeing that this is alive. So that works all good and well, but we have not yet implemented this case where we have another one to the right. So alive, dead, alive. So in this case, we also need to look to the right. So we can do the same exact thing here. It's a little bit more complicated, but it's the same as in our for loop. We could say if right is less than grid.length to know if it's in bounds, and then we check if grid right is alive, and then this works out. The less explicit way that I was talking about before is we can just end up deleting this bit here. And since JavaScript is perfectly fine with us indexing out of bounds, then we can totally do it. But I think it's nicer to validate that it exists. It's a stylistic thing ultimately. Any questions with this function? All make sense?
Yeah, looks good.
Perfect. So now all we have to do is hook it all together to listen to our rules. I'll move these rules up here, make it look a bit nicer. So all we need to do is get our live neighbors and the new state. So the live neighbors, we pass in the grid and the index. I'll also comment these out for. And then we need to pass this in to our get new cell state. And we can see the new states. For now, we can just log this new cell state, but later on, we're going to have to put it into an array. But before we do that, let's make sure this works as we expect. So if we have something like we've been using that same example, so I may as well just use it here. If we have alive, dead, alive, we would expect in this case, we should be getting, let's find out. This one has, the first element has no live neighbors, which means in this case, it's going to die. And the middle one has 2 live neighbors, which means it'll be overcrowded and also die. And then the right one has no neighbors, so it'll also die. And that is exactly what we end up with here. I'll quickly move this into an array. I'll call it next state. We can just push this instead.
When we're determining state, is it based off of like a screenshot of what it was for everything in the matrix, or is it like rolling to where if one of the neighbors dies before it iterates to the one to the right, like would that have an effect on it, or does that make sense?
Yeah, that makes sense to me. Each cell updates according to the number of live neighbors. So it doesn't say specifically. I mean, looking through the examples, you can see that it's based on like the initial state. So like it all happens instantaneously. So in this case, I wouldn't say like this left one dies and then this one only has 1 live neighbor and becomes alive, and then we go to the right, because then that would have to define like a whole new complicated order of iteration, which the examples don't abide by, and there would be more description on how exactly that works as well. I just have
Okay.
seen this problem before, so I know that this is the case, but I guess suspend your disbelief and believe that it is right.
Okay.
That is a good question, though.
Thanks. It's still very difficult for me, but that would have made it much more difficult, I believe.
Yep. So we've covered the case of alive to dead and dead to dead, but we still haven't covered these other 2 cases of dead to alive and alive to dead. Oh no, we haven't done alive to alive. We've just done dead to dead and alive to dead. So let's do both of those. So an easy way to make one alive and alive to alive is something like this. We have one alive which has 0 live neighbors. I guess this one does die. So maybe we do alive, alive, dead. In this case, this alive has 1 neighbor, so it lives. This alive has 1 neighbor, so it also continues to live. And then this one has 1 alive neighbor and becomes live. And then we'll have 3 alives.
Maybe if you whiteboarded these, it would have helped people understand. Just a suggestion.
You'd like to see it on a kind of whiteboard to see it out better, rather than just pointing them out with highlights.
And that would be more like visually like understandable, right?
Okay.
I mean, just want to know everyone's opinion on this.
I'm fine either way. I'm following along, but if Jake was willing to do it and it would be helpful towards you, I don't have a problem with it. That would be cool. But it's totally up to him.
I don't mind either way. And it shouldn't take so much time to do, because I already have these examples here. Wow, that did not copy. Wanted. Can everyone still see? Oh, that you cannot see that on Discord. Okay, can everyone see the new whiteboard?
Yes.
Okay. So in this first case, we have alive, dead, alive. So we want to count up the amount for each one of these of the live neighbors. So the first one, alive, has a dead to the right and nothing to the left, which means one live neighbor. Or sorry, 0. Okay, 0. And then dead has one live neighbor to the left, one live neighbor to the right, which means 2. And this live final one has a dead to the left and nothing to the right, which means 0 again. So this alive one becomes dead because it has no one around it. This dead one stays dead because it's currently overpopulated. And this live one is also dead due to underpopulation.
This game is depressing.
It's supposed to look more cool. Does it not show like the game of life and the I guess it never shows it. We'll look at an example of game of life after this. Or now. I'll just close this tab. I have a tab limiter, so I run out of tabs. Oh, even okay, perfect. Google does it for us. You see like in the corner, like these blocks that are moving around.
Yeah, I didn't know it was an actual game.
Yeah, like it's not so fun now because we have it in one direction. So there's not all that much that can really happen. But in this particular case, like with this 2D version, it's moving all around the screen. And you'll see there's some cycles. It moves around. It looks kind of cool, which I
That
think
is really cool.
it would have been cool if Recode Camp had also shown this bit. It's just, it's a common problem because it's a famous kind of program. And there's websites where you can play around with it and throw random different stuff in here. Yeah, like I can put different blocks in here and see it out. So this one seemed to just move down and to the right.
It's awesome.
I can add some more blocks. It
And you
does
can
something
drag
different.
around. That's it.
Oh, cool.
You can
No, I
create
mean
like an
when
entire
you're drawing.
ecosystem.
It does not let me drag. Draw, I have to click. Unless I'm missing something.
Such.
Yeah, very sad. Yeah, let's go for our final example over here. So in this example, this alive has nothing to the left, alive to the right, 1. This middle alive has 1 alive to the left, nothing alive to the right, it has 1 dead to the right, so 1. And this dead has 1 to the left, nothing to the right, so 1. Was that more helpful to see drawn out this way?
Yeah, definitely. For sure. Really appreciate you doing that.
Cool, sounds good. I'll do that for the other as well. Okay. So we have our 1D version completed, which is relatively simple. But now we need to move on to an entirely new dimension, which means we have more to deal with in different rules. So for our neighbors, we now have 8 of them instead of 2. So we need a way to iterate over all 8, and then we have different rules for the amount of live neighbors. So I'm going to grab this and we can update our get live neighbors. Well, actually, we wanted to do the new cell state first. I think that's easier. So any live cell with fewer than 2 ends up dying. So starting out with that one, so any live cell with fewer than 2. So this one then becomes dead. 1 and 0, great. This one already works. Any live cell with fewer than 2, or with 2 or 3, continues to live on. So let's do this one. So if it has 2, it should continue to be alive, which does not seem... Oh no, it does work. Or does it? Okay, yeah. The only one that's failing now is that we need this alive one with 1 to then die. Did someone have a question? I heard an unmute.
No, I just joined.
Oh, sounds good. Oh, this is what I'm doing wrong. I have my new cell state. Did I do that for the whole thing? I guess I did. I've been typing in 1 and 0 for these, but I didn't actually do all these test cases. That's great. These are the curse of using numbers instead of something easier to work with. So cell state, yep, that's what to expect. 1 0 0 1, and then 3 is invalid. So if it's live, and the live neighbors is 2 or 3, so it is I'll just say equal to 2 or 3, that works. Then this should be alive, and then we can say let's see through if there's something like that for the other. I figure if it's fewer than 2, it's going to continue to die. More than 3 for live, and then a dead cell with exactly 3 becomes alive. So we could just say if it's less than 2, it ends up dying. And that will work here. Yep, and that works out for these cases. And then if we have, yep, we already did this one, and then a live cell with more than 3 ends up dying. So we can pick something like 8. And I would think we could probably do something similar here. So if it has more than 3, it's going to die. And then it only comes back to life if it's 3. So if it's greater than 2, or live neighbors is greater than 3, then we'll return dead. So yep, looks right to me. And then we still need the dead to alive case. So if it is dead, then it needs exactly 3 neighbors to become alive. So if it's 8, it will continue to be dead. If it is 1, it'll continue to be dead. But if it's 3, then it shall live. So we can say if live neighbors is 3, then return alive. And we can simplify this bottom bit here. And here we shouldn't be able to handle any other states, so we should never hit another state. They'll just say unreachable, so if we ever hit it, we'll find out for sure. Oh, we'll add more debug points or debugging information if we end up failing this one. Yep, any questions on this bit? Sounds good then. So now that we have this cell state working, let's try and refactor the live neighbors. And in this case, it's going to be quite a bit more complicated. So going with something simple, we can go with something with no neighbors at all, and that should be a 0. And we expect this to be 2-dimensional now, so this should be 0. Looks like it stays 0. These will actually continue to be valid, so we can leave these here. Except for they're valid beyond the fact that we also need a row and a column. Oh well, for now, to get this working, we can set grid to just the row. And then these will continue to work. So we can quickly rename this to row and then have a column here. Make sure this still all works. I guess we actually want the column here. So I'll move these. So we can do row and row. And we get 0. We expect 0 in this case. And then we get 1 instead of 2 here. Oh, okay, that makes sense. So instead of grid here, we also want grid of row.length. Yep, that works. Does this make sense so far? The refactor?
I can understand it a little bit better, to be honest.
Okay. Anything you want to go over, or just keep going and see where we're at once we finish out this bit?
No, you keep working your magic. You keep going. Don't stop. We're good.
I mean, may as well explain if you have questions before we go too far. Okay. So yeah, now at this point we have our old cases working again with our 1D, 2D, but we could pretty easily do multi-column. I'll say grid here, just to make it a little bit nicer to look at. Grid is equal to the old grid. So let's just do the max of 8 live neighbors. So this is currently the row instead of the column. I like flipping these, so I'm gonna end up doing that. And then just switch these to also contain a 0. So these continue to work, but here I want to get item 1, 1, which is row 1, which is this middle row, and then column 1, which is this middle one. We expect to get 8 out of this one. So here we have grid rows undefined. Not working so well right now, but let's find out why. So we're going left and right, but now we need to think a bit different here. We don't have just left and right. We have top right, top left, all of these. And we could go through and check if everything's in bound all around and have 8 variables for all these, but I find it easier to just end up using an array of different coordinates for me. So let's get that working first. We can see it out. So our left in this case would be equal to 0 for the delta for the row, and then -1 for the delta for the column. And then we have the same thing here, but with +1. And then we can loop over these coordinates and see it out. We call this chord. Or actually, we can do roll call again.
So, Jacob, is that are those the items to the left or the right of it?
In this case, these are deltas, meaning this is the difference. So like in this case, we keep the row the same, but we go to the left on the row. or left in the column, sorry. And here we go to the right in the column. So in this case, I add this to the column number, and I add the left in here to the row number.
Okay.
I think you'll see it out once I type it in here. So we get these new coordinates out of this. And then we need to do the bounds checking in a more generic way. So we want to say, is the row in bounds for the row first? So if new row is greater than or equal to 0 like we had. And then we also want to know if new call is less than grid of new row dot length. And then we finally want to know if grid of new row of new call, if that tile is alive. And if that tile is alive, then we want to say live plus equals 1. So this seems to continue to work for this, but my grid is still broken for this one. The grid of new row is undefined, @ 0.11. So let's debug a little bit. New row is 1 and new column is 0. Let's say the row here is grid of row. This is undefined here. I wonder why that is. The new row is 1, and it should have this accessed in here. I'm sure I've done something silly in here. We'll also look at the grid. Our grid is just undefined in here. Why is that? Oh, well, I have a syntax error here and it just didn't yell at me, I guess. There should be commas here. That is very interesting. Has anyone run into that before?
I know that for free code camp, it's not like homework. They won't necessarily give you a lot of like hints if something's wrong just syntactically.
Yeah, that's
They
very
might be
interesting.
they might be using CodeMirror or something and not have everything enabled in the console.
I run this in the browser console. Will it yell at me? alive is 0. I guess I don't need to define anything else. This works in regular JavaScript. Okay. So it's nothing with pre-codecamp. It just seems that for whatever reason, this JavaScript outputs an array with one item that's undefined. I don't know why exactly that is. Probably this expression's returning. Who knows? I won't worry about it now. I'll probably look into it after and I'll let y'all know, but that's always fun. But adding this back, we should get back 8. And we get back 2. So let's see. Oh yeah, that makes a lot of sense. We should expect 2. I forgot we didn't implement it all the way. We expect to get back 2 because we only put 2 directions in here. So now we just need to add in the rest of those and we should see it start to climb up. And the rest of these should stay the same. So we have left and right now, but we also need top and bottom, which would be the same as flipping these. So 1, 0 would be bottom, and -1, 0 would be the top. Good to know we're failing now. So it's failing on this first one. We'll add back our log. So new row is always greater than 0. Oh, that makes a lot of sense. So I haven't done the bounds checking entirely correctly because I only checked if this was greater than the leftmost bound, but I have missed the rightmost bound, of course. So we also need to say new row is less than grid dot length. And then of course we're going to put the analogous bit in here, which is new column should also be greater than 0. So new col is greater than or equal to 0. We could probably make some nice helper for if this is in bounds or not at one point, but I'll say in bounds is this for now. So yep, now we have 4 of 8. That works out. And we need to get all these diagonals in. So if we want to go diagonally to the left, we can just do -1, -1. So in this case, -1, -1 goes back 1 and back 1. That's this top left one. Bottom right is 1, 1. Then we need to do these top right ones, which in this case would be -1 to go up and then 1. So -1, 1, and then our final one is 1, -1. That should give us all 8 of these. Let's just pick another one that has some dead sprinkled about. And this looks like we have 1, 2, 3, 4 that are alive. get back 4. Looks like we do. And then let's pick another case where we're picking a different one in here. So let's say we pick the bottom right one, which in this case would be 2, 2. Because we're going down to the second most row and then the second column. And then in this case, we would have 3 alive all around, and then the rest are missing. Let's make this one dead, and then we can say 2. And we do, indeed, looking at the right, get 2. Any questions on how this works? Does it make more sense now?
I'm definitely gonna have to rewatch this video, but I'm doing the best I can.
Yeah, sounds good. So then the next thing we need to do is handle this full function with this, and we ideally have minimal changes beyond we need to hit our we need to deal with rows and columns, which will change how we deal with our state, and then as well as how we iterate over these things. So we can start out by making these two-dimensional. And we're getting error unreachable for the new states, probably because we are checking new cell state on an array, which is never equal to any of these things. And we should not do that. And we can pretty quickly validate by console.error in here. Cell state. Yeah, we get 0 and undefined. Well, I guess that undefined is a different reason why, because we should be giving the cell state, which would be grid row column, which in this case we can say 0 and I. Which then gives us the wrong things again. I'm not going to worry so much about getting this perfect again. We can take this as an example and then move on from there. Let's just start from the basics. I'll get rid of all of these. And then in order to loop over these things, we're going to need 2 loops. One to loop over this first bit, and then another to loop over the outer array. Actually, I think we can do the same thing we had before. We can say grid of 0.length. Yep, that works for us. The rules have changed around, so it's not going to work perfectly. Let's make sure that still makes sense. So if this is alive, we expect these rules are no longer the case. I'll move these up here because we'll be needing to look at them later. So a live cell with fewer than 2 live neighbors dies. And then 2 or 3 lives on. And it looks like in this case, any live neighbor with 2 cells will live. And the dead ones will, I think, permanently stay dead. Yeah. So we expect this one to stay dead, but then this alive one has no neighbors, this alive one has no neighbors. So that means it will also die. And ones with exactly 2, which is nothing, end up all dying. So in this version, even more grim than before, they're all just dead. So now we just need to do the same exact thing, but for multiple rows. Let's grab one of the ones we already had here. And make an example. So in this case, we have alive, dead, alive, dead, alive, dead. So we want to call game of life under grid. We don't pass it to, we instead get our expected. I'm gonna grab all this. Yeah, and that's not so easy to read in this specific case. I did write a helper function in case this occurred, which is 2D array equal? And we can just validate that these are equal. Yep, so in this case we have false for this case. These are not the correct answers, which of course it makes sense because we didn't update these. But looking into this, we would say any live cell with fewer than 2 live neighbor dies. So in this case, this one must die because it only has 1 live neighbor. Then this one is dead, but it has 3 live neighbors, which means it should come back alive. And then this one to the right has 1 live neighbor and it's alive, so it should also die. I think these rules are easier to see than the other ones. So less than 2, greater than 3, it'll always die. And then if it is 3, it comes alive, and then 2 and live stays live. So going down to this one, we see it has 3 live neighbors. Well, actually, yeah, it still has 3 live neighbors, so this one becomes alive. This middle one has 3 live neighbors, so it stays alive. This right dead one has 3 live neighbors, so it should become alive. This bottom dead one has 3 live neighbors, so it should also become alive. This bottom live one has 1 live neighbor, so it will die.
One second, Jacob. The previous one before that, in the bottom left-hand corner, did you say that it had 3 live neighbors?
I think I did, but it looks like it has 2. Good catch.
All good.
Yeah, thanks for checking me. So this one's dies, and then this one had 1 live neighbor, so it's remains dead. Okay, and we're not getting our expected output, which makes sense because we ended up not handling any of the others. So we would expect to see in this case that it'll only affect the first row and return us a one-dimensional array with the correct first row, hopefully. Let's get rid of these 2 for now. I did not log that, of course. So here we get an empty array because I am not returning. Oh, I am returning the state. I guess I'll have to see this one out too. So yeah, this looks like this one's not running at all. So grid of 0.length, in case we expect to be 3. Let's log that too. Yeah, so this seems to have 3. But it's never running this inner. I wonder why that is. So we have I needs to be less than grid 0 length. So let's say grid of 0 that length, which is 3. So I needs to be less than this. Oh, we're getting undefined in the other case. That will do it. I have called Game of Life on top of Game of Life. All of the joys of being used to an editor that will telling me these things earlier. Okay, so great. This now at least returns the same result in both of these, and we get the expected 000, or maybe not, we get dead, alive, dead. Does the new cell, yeah, new cell also, yeah, makes sense. We pass it the wrong amount of arguments, and this playground does not care where we are at. New cell state is fine. Get live neighbors, however, needs a row and a column. So our row is 0, and I is here. So 0, 1, 0, dead, alive, dead. This one is fine. And checking these ones too.
Nice.
Nope, it is not working here. See these out, and I have run into the case where I finally need to log something. Do console error work here? It does. It does not show the error though. State and left. So we're getting back cell state of dead, live neighbors 2. Oh, that makes sense. Yeah, I never handled that case. So it should be dead in this particular case of if it's dead and live neighbors are 0 are 2. I think it's fair enough to just return dead at the bottom of this. Then make sure it all works right in our cases. So if it's 2, so 0, 0, 1, 1, yeah, all these look fine to me. So now this
And then
case, go ahead.
your second if statement, it handles both live and dead for the current index, correct? The second if statement?
This one? Yep,
Yeah.
indeed. Because if it
All right, cool.
the rules say if it is 3 and it's dead, it should come back to life. And then if it is alive and 2 or 3, then it continues to live. So it covers both
Oh,
cases.
yeah. Yeah, it did say 2 or 3.
hmm
That's right. Thanks.
So now that we're through all of that, I guess console count just doesn't work. Because like it's clearly doing things in here. Yeah. Console count just does not work on this playground. So this works for our now one-dimensional or our now two-dimensional matrices, but we need some way to loop through all of these and do the same thing. So briefly, I shall just end up looping over these. So the easiest way to loop over both, in my opinion, is saying just changing them to row and column and having multiple loops in another loop. So row is equal to 0 and row is less than the grid.length, and then row plus equals 1. And then we do the same exact thing with columns. So I can more or less copy this bit. But now row is column. And instead of grid.length, we want grid of row.length. And let's just check by console logging. Grid row of call, you'd say row and column. I am missing a bracket. That will do it. So in this first case, we expect it to do 3 times. So we have 1 alive, dead, alive, 1, 0, 1, which is expected. They're all in row 0, and then we have 0, 1, 2. And then skipping down to this two-dimensional one, we should expect to see 1, 0, 1, 1, 0, 1, and then 0, 1, 0, 0, 1, 0, and then 0, 1, 0 again, which we do see. And you can see the rows go up 0, 0, 0, and then it goes up 1, 1, 1 when we get to the next row, and so on and so forth. I'll annotate those real quick to make it a little bit easier. So we're iterating each column for the first row or for the 0th row, and then we move on to the next row, do the same thing, and then the next row and do the same thing. So very similar to this, except for we want to loop over each row as well. And I believe we can take the same thing. For now, I'm going to do it incorrectly and push to a one-dimensional array once again, but we can always make it two-dimensional in the future. So instead of 0 and I, in this case, we want row and call. Same thing here, row and call. And then return new state. It says new state. Okay, I spelled it wrong. It is next state. That'll do it. So yeah, here, let's see if this is what we expect. We expect a 0, 1, 0, 1, 1, 1, alive, 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 and then dead, dead, dead. And we do indeed get that. But of course, in this case, we don't have the full array here. So we need to do something like saying next row is equal to an empty array. And then next state dot push next row. And then we can push to this reference, and that will handle that pretty easily. We now have this in arrays as we expect, and we get back true. So 0, 1, 0, 1, 1, 1, 0, 0, 0, split into multiple arrays. Any questions here? Sounds like no. I think we may as well test the example they give us. So let's do that as well. And it looks like it works here, at least. Oh well, I'll leave the formatting here. We can fix it up later. Let's see if it all works. Indeed it does.
That was amazing, dude. That would have if that was a technical interview question, I would have just walked right out of the room. That was incredible.
Thank you.
It's been really cool, like, the last 2 nights, seeing how you set your tests up ahead of time, and then you work through cases and edge cases, and then methodically think about what you have to do and just start implementing it. It's really amazing. Like, I had an idea of what functional programming is, but, like, watching you work, it's not it's a lot cleaner than what I had in my head.
I wouldn't say it's necessarily functional programming, it's just I happen to use functions while programming.
That's so funny.
Yeah, I won't be too, what do we call it? Code weenie, that's what it is. I will not be a code weenie and give you a big explanation, but I would
No,
not
by all
consider
means,
this.
be a code weenie, dude. We really appreciate you. Like, this is awesome. I would have stared at this for like a week and not gotten anywhere.
Before I end up closing this off, does anybody else have any questions about this? I'll make sure to throw the code in the chat and everything. And it's also, even though you say methodical, I like how I managed to miss test cases even so.
It's not, you're probably used to like your editor and looking on, things the way you're used to looking at them. So it's really easy to miss stuff. So, I mean, I wouldn't get too hung up on that. I mean, you clearly know what you're doing. It's really amazing watching you go through it.
I forgot. Do you have a YouTube or where is it that this is going to be uploaded?
Yeah, it'll be on YouTube. I'll post it in the Ketchup Crew channel.
Awesome.
Ooh, I'll end it off here unless anybody has any final words.
So is every I don't know what we're calling this, but are we gonna record every single one of these going forward?
It's probably up to whoever is doing it. I feel like most of the time it probably won't be. But I figured this one was complex enough to warrant a recording.
I came upon this problem and it just totally floored me today. So I asked Jacob and he kindly said he would go through it for us. So he's recording it so that he can post it for other people. But that's not something like I haven't done that anytime I was like screen sharing. So yeah, it's just totally up to like whoever's coding.
Oh no, I think it's a great idea. I mean, like you were saying yesterday, like sometimes, like right now for me, it's closer to midnight. So like whenever it's like weekdays, I think that'd be really beneficial for people that are like at different time zones.
Right on. Well, I really appreciate you doing this, Jacob. It's been really cool the last 2 nights, seeing how you work through everything, especially for a lot of us that are newer to some of these coding challenges. Just seeing how you go about them is really cool. Like I just throw code at the wall, and if it sticks, it sticks. If I break stuff, I just panic and start changing stuff around until I get it working. But this is a more sustainable way of going about it. It's really cool. I just want to say thanks.
Yeah, no problem. I'm glad I got many issues where I ran into not putting commas in my array and things like that to show happens to everybody. I don't think there's ever been a time where I do live coding and it works well the first time around, and if it does, probably something's wrong.